Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through what a function is. So in mathematics, a function gives a unique output for each input. What does that actually mean? Well, this is why functions are important. A function looks like this. It can be written in fx form. So x is the input. We usually input a number into a function. For example, if I want to input -1 into this function, I just change all of these x's to -1. And remember always to use brackets when inputting a negative into a function. So if I were to put this on my calculator, I would just get the number -4. -1 was the input, the value I replaced x with, and -4 is the output. So a function is something like this, where we input a number, we get a unique output. We get one and only one output. So what we need to do is view functions as maps. So for example, y equals 2x is a very simple function. Let's look at it as a map. So what we're doing is we're mapping an input, an x value, to a y value, which is the output. So for example, if I input -1 into this equation, I get the output y equals 2 times -1, which is -2. So -1 gets mapped to -2. Now this set of all possible inputs is called the domain, and the set of all possible outputs is called the range. So I could do similarly for the other numbers. 2 times 0 is 0, so 0 would get mapped to 0, 1 would get mapped to 2, and 2 would get mapped to 4. So what does this have to do with functions? Well, this is a function because each input I map goes to only one output. I don't have a situation where the same input goes to multiple outputs. Now that's actually not true for this equation here. So still using the x values as my input, if I were to say input the number 1, if x equals 1, y could be -1 or +1. So this map basically says if I have an input, an x value, find which numbers need to be squared to get that input. So I have a situation where the same input is mapped to multiple outputs. Even if that only happens once, that's enough to conclude that this is not a function. So it turns out to determine whether or not something is a function, it's really easy just to look at its graph. Okay, so we've got all of these graphs here. We want to determine for each one whether or not it is a function. So when I'm asking, say, is this a function, I'm asking, are there instances where the same input, the same x value, is mapped to multiple y values or multiple inputs? So we can test that pretty easily using the vertical line test. So each of these will be a function if and only if it passes the vertical line test. Passing the vertical line test means you cannot draw a vertical line that hits the graph more than once. So if we look at this first graph here, it passes the vertical line test because any vertical line I draw will not hit the graph more than once. Accordingly, this graph here is of a function. So let's look at this graph here. Sometimes you'll see weird graphs like this where it has dots. So if the dot is shaded, it means that the graph passes through this point. We include this point because it's shaded. We don't include this point up here because it's not shaded. So it turns out this too is a function. Any vertical line will hit the graph at most once. Even if I drew a vertical line down here through these points, it only hits the graph once because we're including this in the graph, but we're not including that point in the graph. On the contrary, for this one, we have two shaded dots. So both of these points are included on the graph. So if I draw a vertical line down here, it actually hits the graph twice, here and here. So this is not a function. As you'll come to learn in maths, disproving something is easier than proving it, because to disprove something, you only need one counterexample. What am I going on about? All you need to determine that something is not a function is just one vertical line that hits it more than once. One is enough to stop it being a function. So over here, this one is clearly not a function. There are so many vertical lines, in fact, infinitely many vertical lines I could draw that would hit the graph more than once. So not only are we interested in whether or not something is a function or relation, we're also interested in whether it's one-to-one or continuous. So the graph is one-to-one if each element in the domain maps to only one element in the range. What we do to test this is use the horizontal line test. So that's very similar to the vertical line test, but you use a horizontal line instead. So this first function here is not one-to-one because it fails the horizontal line test. I can draw horizontal lines that hit this graph more than once. So because it fails the horizontal line, it's still a function, but it's not one-to-one. When I'm saying that this is not one-to-one, what I'm saying is there are instances where the same y value corresponds to more than one x value. So for this function here, it is one-to-one because if I draw any horizontal line, it will hit this graph at most once. There is no horizontal line that hits this graph more than once, and so this is one-to-one. That means if you have a different x value, a different input, you get a different output. So this graph here is not a function, it's a relation, but it's not one-to-one because we can draw a horizontal line there that hits the graph more than once. And similarly, the last one is not one-to-one because it's possible to draw a horizontal line that hits the graph more than once. So what I mean when I say this is not one-to-one, there are times where you have the same input, the same x value, but it gives you different y values. So let's check whether or not each of these is continuous. So to check whether or not a graph function relation is continuous is really easy. You just look if there are jumps in the graph. So clearly these two have jumps in their graph, so they're not continuous. Think of it like this. If I were to draw each of these using a pen, I would need to stop and lift my pen off the page. If I wanted to draw this graph, or this graph, I could just keep going. I wouldn't need to stop and take my pen off the page. So these two are continuous because there are no jumps in the graph. These two graphs are discontinuous because there are jumps in the graph. And when we have discontinuous graphs, we usually specify where they're discontinuous. So here the jump is at x equals 2, here the jump is at x equals -1. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.